Welcome to the Modern Industrialist Podcast, where we explore the innovations and strategies driving Industry 4.0 forward. I'm your host, Jason Hehman, Vertical Lead for Industry 4.0 at TXI. Today's episode is particularly exciting as I'm introducing two of my colleagues, Andrew Horner and Alan Gardner. I've had the pleasure of working directly with both Alan and Andrew in the recent past on multiple industrial IoT projects where we've helped manufacturers collect and analyze real-time data from their production environments. This experience is particularly relevant to today's topic of digital twins, since the data gathered through industrial IoT sensors and systems often serves as the foundation for building effective digital twin implementations. Andrew is a principal engineer at TXI with over 12 years of experience with us in application and custom software development. Alan is also one of our principal engineers, and he brings more than 2 decades of experience across startups, Fortune 500 companies, and has expertise in full stack development and AI applications. Digital twins are transforming how industries operate, but there's often confusion about what they really are and how to get started with them. Throughout our conversation today, we're going to explore how digital twins can range from simple data collection systems to complex predictive models, and why they don't always need to be as complicated as they sound. There are 3 key insights you can expect from today's discussion. First, we'll demystify digital twins by exploring everyday examples, from things like smart home systems to navigation apps, showing how this technology is already part of many of our lives. Second, we're going to discuss practical applications for getting started with digital twins, including how simple data collection with basic sensors can provide immediate value. Third, we'll explore how digital twins can serve as assistive tools rather than prescriptive systems, and how this approach can lead to unexpected insights and operational improvements. What makes this conversation particularly valuable is that it draws from our shared experiences implementing these systems in real industrial settings, situations where we've seen firsthand both the challenges and opportunities that they present. So, without further ado, let's dive into today's discussion about digital twins. Andrew and Alan, welcome to the Modern Industrialist Podcast. It's great to have you guys here. I've been looking forward to doing this one.
Yeah, I'm looking forward to it as well.
Likewise.
I love a good roundtable episode when we can get a couple of voices going simultaneously. So the thing that we were planning to talk about today is digital twins. And I feel like I would be remiss if I don't kind of come off the top rope first and set out the formal definition of digital twins. This idea that it is a dynamic digital model that uses real-time data and simulations to analyze, predict, and optimize performance. So, great definition, super formal, very detailed. I've found that in a lot of cases, people think of digital twins as merely a digital simulation or a digital representation of a real-world thing. And they kind of stop at that understanding or that level of complexity. Whereas I think we've been talking more deeply about the broader sense of these things, the real life and the digital component being somewhat linked. So let's just curious from either of you, like how have you heard people talking about digital twins, or do you think I am off base in saying that the simulation is kind of where a lot of people's conception of it and idea of it tends to stop?
I think it can be that for sure. I think digital twin to me, at a baseline, it is that digital representation of a real world object. It's at least like one data point or a collection of data points that let you know something about what's going on in the real world. I think for me, what you do with that information is it matters a lot more than like whether or not you're being true to the definition of digital twin, right?
Yeah.
You can have a digital twin that you use to make useful predictions for something. I think generative AIs are like a digital twin of a conversation partner oftentimes.
Oh, that's interesting.
You can plug in a bunch of context and then like have that context represented in the following conversation. So that's like one thing that I've been kind of wrapping my head around. But I think to me, a digital twin It doesn't necessarily need to go the whole 9 yards in terms of like I can make changes to the digital twin and they're reflected in the real world. But that's certainly a direction you can take it, right? I think at the end of the day, what is important about a digital twin is that it gives you the ability to reason about the real world object with a lower cost than actually interacting with reality.
I buy that. I buy that. Alan, what say you?
Yeah, I'm kind of feeling the same way as well. I think about it in the way that I think about a lot of software, in that it's it's got to have some value to you to have it there, but it doesn't necessarily have to be a value as defined by a governing body or, any particular brand or something along those lines. I think you find your own value for the thing. Um, for example, I think it would be fantastic to have the situation where you have a digital twin that can be receiving data in real time so that you know how it's actually performing right now. But that doesn't mean that if you are, for example, performing a study, which has a limited timescape, that digital twin isn't useful after that study, even when the real-time information isn't coming in, because you still have the model of that particular point in time. I think when it comes to the digital twin also affecting the surroundings, affecting its real-world counterpart, I think that's a fantastic use case. But for me, I'm still not convinced that that's a necessary part of a digital twin. I think it may be like a final state or one of the final boss modes of it. But I would be interested to see how things like, for example, the shopping cart app you were talking about before, it's very much modeling the items that are in your cart, but you can't swipe something off the list in your app and then it disappears out of your trolley back onto the shelf because there's limitations in real life. So I think the digital twin can be useful in its own right without necessarily having to fulfill an entire definition.
So I love that you're going down the road of examples of digital twins in everyday people's lives. I think that to a certain extent, there's a lot of application that we can take from some of these as we try and conceptualize it. So one of the ones that I think is kind of obvious is as we think about the connected home, right? So to the extent that you have off of an app on your phone, the ability to change the lights in your house, put your drapes or your blinds up or down, change the temperature of your oven or stop it or start it. I think that network of connected device within the home fundamentally becomes a digital twin of that environment, right? It's giving you kind of real-time updates of things status. And you do have that return path in a lot of cases as a way of impacting the real world environment with the touch of a button or the use of a dropdown.
I think the examples you're giving tie into like something else that I think is like part of the definition of a digital twin, which is it's an interface, right? Mm-hmm. You aren't necessarily able to impact the actual temperature of your refrigerator. You can trigger something that's going to change the temperature of your fridge or your oven or whatever. I've got a Nest thermostat. I can't actually change the temperature of my house, but I can tell the thermostat to like try and get warmer, right? So there are levels of fidelity here at play, right? I can push a button and change what my thermostat is doing in terms of warming up or cooling down my house, and my thermostat will tell me like what temperature it is in my entryway. It doesn't necessarily know what the temperature is upstairs, so it's not a complete model, but it's good enough for me to like take care of things most of the time.
I think that's a really interesting point, actually, because it leads on to thinking about these things in terms of not necessarily defining things that should happen or setting up ingredients or steps that should play out. You're describing a rule or a thing that you want to have happen, right? I want this room to be 18 degrees Celsius or whatever that is in Fahrenheit. You're not saying, please turn up the heat in this room or please do this. You're describing a desired state and allowing that system through the digital twin to self-set. And I think that's a really interesting part of digital twins when they facilitate the knowledge that the system needs in order to regulate itself. So that bringing in the automation aspect.
Yeah, absolutely. And I think it's there's a lot of conversation to be had around like the user experience of a digital twin, right? There is a very basic version of a thermostat where it's just plugged into my wall. I can see what temperature it is, and I can like manually push it up and down. I think Nest was at least the most popular, if not one of the first versions of a thermostat that tried to actually work towards a specific goal where you want your house to be a specific temperature and it'll move toward that, and tries to do some predictive things around like scheduling when your temperature should go up or down. So it adds a lot of niceties onto the traditional thermostat experience.
I love the idea there also in terms of the complexity and the interplay of systems from a predictive standpoint and the machine learning aspect of it, right? So staying in this kind of house example, the idea that there's an observation that the house temperature naturally rises at midday, right? And what does that mean in terms of raising or lowering of blinds to accomplish the task of raising the house temperature as opposed to going to the thermostat, right? Like that type of multivariate understanding of the input factors that drive the outcome starts to get super interesting. The thing that you brought up, Andrew, in terms of the potential for scenarios, makes me think of my other favorite, real life consumer example of digital twins, and that's like any navigation system, right? Mm-hmm. Whether it's you're using Google Maps in your car or Waze, I think of it as a pretty good model for a digital twin because it's a visual representation of a task that you are completing, right? You see your car in the interface, your car exists in real life. When the status of your car changes in real life, it changes in the application. The application is working through you, basically, to get the car to change and to follow the prescribed path of what it is that you're supposed to be doing. But to your point about scenario planning, the idea that it's running in real time a number of scenarios that are potentially more optimal to complete the task that you're trying to do based on changing conditions is super interesting to me. And the idea that it'll correct if you deviate off the path and give you a new solution almost instantaneously to get you back towards that goal. So again, I think it touches on what you're saying before in terms of the, if not directly impacting the outcome, kind of like pulling levers, if you will, or giving nudges or indications towards the actor, be it a person or digital, back towards that desired outcome.
Yeah, absolutely.
Yeah. I think a piece that's really interesting here as well is the way that an app like Waze or Google Maps course corrects, like literally course correct. Mm-hmm. It doesn't tell you, oh, you've missed a stop, or you're this far off latitude, longitude. It says, take the next left, or perform a U-turn and then do this. It will immediately start giving you useful information. And I think that highlights the difference between tools that give you a dashboard that show a bunch of running real-time metrics of things that are happening, and something which says, oh, this machine's running hot right now. You might want to go and have a look at it. Or already goes and checks and sees, oh, actually, the maintenance on this machine is due anytime soon. I think I'm going to move that up in the schedule. And it doesn't tell you this machine's running hot. It just says this machine is now due for maintenance next week. I think that's a really interesting aspect of digital twins. I don't know how necessary it is to the nomenclature, but I think from a user experience point of view, it's an important aspect.
I think that the like heads-up display nature of a map app as a digital twin is an interesting one. I like that you've called out the kind of course correction, both of you, because I think a really important part of a user experience when you're interacting with a digital twin is that it isn't too prescriptive about exactly what's happening. It's responding to what's happening, and it's still giving you useful information. But if it works with you, right? If I'm driving and it's telling me to turn left and I see that the left turn is actually blocked off because the map hasn't been updated recently enough and there's like a road closure, I can just keep driving and it'll figure out where I should go next. Or if I decide, oh, actually, I'm going to turn right because I think this is actually going to be a slightly more convenient route, it'll work with me on that. The idea of a digital twin that's kind of trying to help you along as an assistive tool, as opposed to something that is trying to that's trying to like force you to do a specific thing, I think is like an important aspect of a good digital twin.
Yeah, I think, maybe shifting away from the consumer-centric viewpoint we've just had, I think it's telling that, the oil and gas industry was basically the corner of the industrial world where digital twins really kind of took hold. And I think there's a couple of good reasons for that are probably instructive for where digital twins add value, right? So in oil and gas, it's high stakes operations, right? So the cost of failure or downtime in those types of operations is really huge. Each decision about maintenance, right, has financial implications. I guess I would say that they're complex, right? So these platforms, these refineries are really complex system with a lot of interdependent components, right? It's like one large continuous operation where a problem at any one spot creates bottlenecks and downfield or downline problems. If you think about the type of machinery in that type of environment, like it's data rich. There's lots of easy ways to pull data from pumps, from temperature that are high related. So it was easy to get access to data. And I guess get back to the other point, there's enough financial risk and impact, right, to make it worth the investment, both in the OT infrastructure as well as the software to kind of get that piece of it. So I think broadly, those are like good indicators broadly for where digital twins could add value. What did I miss? What are some other, would you guys say, ways of identifying places where digital twins could add value? Like, what's a good leading indicator? Like, hey, this would be a good place to potentially apply some digital twin technology or some thinking.
Yeah, I think identifying those ROI opportunities, right?
Yeah,
You've kind of called that out. It's really important. If you have the ability to assess how much throughput a particular like drill or well has, and you can tell when that value starts to dip, you know that you need to perform some maintenance immediately, as opposed to like letting it deteriorate further and further. The utility here for digital twins would be around like modeling, my ability to get out ahead of a problem. So I think places where very fast reactions are valuable would be like one place that you might want to insert a digital twin into your workflow. If something going offline is a problem for you, get something in place that'll let you know when that is more likely, so that you can get out ahead of it.
Yeah, I think the first place I came across digital twins actually was back in the early 2000s when I worked for an oil and gas company. My job at the time was planning offshore shutdowns. Those shutdowns cost millions of dollars per hour. The platform shut down because it's not producing. And one of the things that we realized from running a simulation, because you've got all the 3D drawings, those CAD files that are available, you know what you're building topsides, plus you've got all of the Monte Carlo risk simulations that you've been running on the run up to it. So a lot of those things feel like, oh, this is what the digital twin's for. But one of the biggest eye-openers that we had on that was realizing, oh, we've got this job on a hydrocyclone and a job on the pipelines that are scheduled to run simultaneously, but they're right on top of each other. And we'll have to fill out a bunch of dropped instrument reports if we go in and deal with that. So let's swap the jobs around so that we can do that differently. And it's just things that you don't realize until you can actually see what you're looking at. Now, I know a digital twin doesn't necessarily have to have a visual aspect to it, but I think in this particular case, that was super powerful. And it's something that we wouldn't have had without spending money for, 3-4 people to go offshore on a helicopter for a couple of day trip to walk the job and do that.
So that's interesting. Like, let's just double click in on that for a second. 2 points of curiosity. Was the digital twin able to surface that conflict for you, or did you come across it through your visual observation of the data? And how what was the degree of fidelity of what you were looking at? Was it truly like a semi-visual model, or are we talking about, figures and numbers and more abstract representations?
Yeah, in this particular case, it was 3D a 3D model in. I'm trying to remember the name of the tool now. It was an object-oriented CAD model that they had, but we were able to zoom around that and see, peel back each layer. So show me the modules themselves, show me the pipework, the instruments, the structural supporting steel around about. So it wasn't until we were closing out and introducing the structural steel, just because we wanted to have a look around, didn't actually think it was important at that point because we weren't changing any of it, that it was like, oh, hang on. The folk that are working up there are right above the people that are working down there. That's not going to be a good situation. So we were definitely eyeballing it in that situation. It maybe wasn't, the digital twin wasn't advising us of that, but I don't think we would have seen that otherwise.
I think that ties into like a larger point around the way that you can sort of incrementally improve a digital twin, right? You can start with something that's just like a basic model. You can then situate that model in the kind of like real world setting that it's inside of. And each step you layer on here gives you more information, right? It can be an incremental investment. You can kind of decide when that investment stops being useful. But it's an iterative process. You don't have to start with a perfect digital twin. You can still get useful information out of the more basic versions.
I think in that case, Alan, the lack of easy observability when you're dealing with an offshore oil rig also kind of figures into a great moment to think about the value of a digital twin, right? When physical proximity to the individuals making decisions is not easy, right? This type of technology really kind of adds value and bridges what would otherwise be a real gap in understanding and decision making.
Yeah, absolutely. And the different angles it gives you on that information as well. I mean, eventually what would have happened is the work packs would have gone offshore and the foreman would have walked the line and gone, oh yeah, this is not going to work. But then you've got, in order to get those work packs offshore, you've got to send 20 massive binders offshore, which, not that complicated, but it's a helicopter trip that didn't need to happen. So I think that aspect of it is really interesting. And when it comes to a factory floor, for example, it's one thing to walk around that factory floor and see where things are, but it's very difficult, or at least I imagine it's very difficult to get a big picture view of what's that like, without zooming out or standing on a big ladder to get a look around. So I think from that aspect, just the different perspective that it gives you is very handy.
I think we're doing a really good job of covering this concept of like a digital twin as a model of a complex system. I think the other area where I've seen it applied more recently is in kind of like, I guess you would call it discrete manufacturing, whether it's like 3D printing or additive manufacturing or something like a CNC, right? Where a specific piece is being manufactured, and with each pass, there's a digital twin that's comparing what's being produced to the ideal model of what needs to be delivered, right? And the same way, going back to our Waze example, if you were to veer off of the path, right, what's the optimal fix or optimal solve? And so, right, the idea of a 3D printer as the extruder is kind of going over a layer that had just been laid that might have cooled unexpectedly differently or might have shifted in the process. The digital twin being able to run those scenarios simultaneously can actually help to or give directions on how to solve for it in real time with slightly different pathing or potentially a second pass to keep it in as close as possible to the tolerances for the piece that needs to be delivered. So I think thinking about systems for digital twins, but also very discrete, like individually manufactured pieces is an interesting dynamic of how vast the spectrum of twins can be.
Yeah, absolutely. I mean, we've seen examples of robotic arms, for instance, that are performing surgeries at a very small level. I think the use case for a digital twin is when like the real world granularity of something isn't quite right. Like I can't be at all these factories at once, or I can't make my hand super tiny in order to perform this extremely complex surgery. It lets us scale up and down in a really interesting way.
Yeah, I think the thing that is maybe slightly off topic, so feel free to rein me back in if I'm heading off on a different path here.
Go for it.
Is the idea of a digital twin allowing or giving you insights you didn't even know that you needed. So the one that I have or been looking at recently is in Aberdeen, we've had an issue with taxi queuing. The taxi queues at the weekend are a place that can get pretty rowdy. And we started to realize once we started to put cameras up with computer vision that actually there were very long periods of time when there weren't any taxis in that queue because of the lack of taxis that were on, and the ability to see that in the digital twin and then use the computer vision, the data that was coming out of that to show the curve of what the taxi queuing was like, allowed us to go to the council and say, we need more taxis on the road. So you're going to have to find a way to improve that situation. That was not the intended purpose initially. The intended purpose was so that the taxi companies themselves could see, oh, this queue's quite busy, I'll send some taxis along here. Or so that people could say, which taxi queue do I want to stand at? Do I want to stand at this end of Union Street or that end of Union Street? So I find that interesting, that there's new data or new ways to use them that you didn't know you needed before.
Yeah, I think step one of generating insights is just collecting the data that you can base those insights off of, right?
Yeah.
Digital twins give you a way of doing that because they're able to capture information about the world around whatever you're modeling.
Well, I think that connects back to something you and I were talking about earlier this week, Alan, which is this idea that the path toward the digital twin actually begins with some of the simplest collection points and the simplest of understandings. We were thinking about throughput in a manufacturing environment where if you're coming from a place where you have no data, just having uptime versus downtime measurements across the different machines in the line allows you to do some remarkable stuff in terms of capacity planning, understanding a bottleneck, starting to plan for how you might staff different parts of the line, different parts of the day. I think this gets to our bigger kind of point of view here at TXI, which is that digital twins are not a monolith. They're not a impossibly robust and difficult thing to imagine. They can actually begin with some of the most simple data collection practices and implementation to try and mine insights, as Andrew was saying. But obviously, like that first step is the hardest part, right? And the idea that finding the right places to collect that data and the data that's going to be valuable is what's interesting. Increasingly, I think we're seeing people testing these data collection processes in a variety of ways. I've talked to folks who are just sticking a Raspberry Pi on a piece of equipment, trying to monitor, be it drill rotation speed or electrical current or uptime versus downtime. And those are fantastic ways to get started in terms of the data collection aspect of this.
Yeah, absolutely. I think there are some other examples I've seen on some recent projects around information being captured like at a really high fidelity in order to feed them into other systems that will improve over time. But for a vehicle being able to detect corrosion or fractures or other stressors, the digital twin in that case is actually really like high resolution images or a series of those that you kind of stitch together, and you're able to know where the damage on these vehicles is. And I think that like identifying what information is actually valuable to grab requires really in-depth knowledge of your industry, right? And I think that's something that a lot of folks have. They're, especially when they're working with these manual processes, they know what is useful and what isn't useful. You kind of need to mine that from the folks who are working on the floor, kind of looking at things.
Yeah, it can be quite eye-opening when you start collecting that data to realize, oh, we've taken a photograph of this machine every day for the last 30 days, and it's moving ever so slightly. It's moving, and you realize you've got quite a big vibration problem in that machine, to the point where it's moving along the floor. So these insights don't always happen immediately, but having the data, like Andrew said earlier, collecting the data is the starting point. Once you've got the data, and you're probably collecting this data already, like you mentioned about offshore, there's a ton of instrumentation all over the deck, not to mention other stuff on the platform, and all of that information is being collected. Quite often it wasn't really being used other than certain collection points. And then you've also got data that's coming from ROVs, which is going around subsea to find out how the corrosion's going on. You've got people rope access going down the inside of jackets and stuff to find this stuff out. There's bound to be things, even in the smallest production line, where there's data already being collected, even if it's just your electricity bill, right? So harnessing that data and allowing it to help you to find those bottlenecks in your system, the things that you can improve, or even just when something's going to go pop before it goes pop.
Yeah, I think the future around how potentially, like we're leaning into the predictive maintenance aspect of this, but I think also just the future potential for data interchange among partners and associated firms across a collective that can support training data, right? So I think we've started to see new data on robotics and robotic arms that's being shared across a number of organizations as a way of kind of creating a collective understanding of how best to train, right? And the role that historical training data, like at scale, shared across organizations, can help those firms who are training robotics using digital twins to have a more robust data set on which to train and start to think about the predictive aspect of what they want to do. So I think that, that interchange or that economy of data that can be supported is interesting. I think NVIDIA has been taking some steps here in terms of releasing training models and data behind that. Obviously, I think it's in their interest, given like where they're pushing with their Omniverse product. They're trying to get people to think more and more about how they can do very rich modeling of real world situations based on their own data and shared data to get to these types of predictive analyses for better performance.
I like the way that the augmented reality approach to digital twins kind of ties back into our original like mapping example, right? It brings things a little bit closer to the consumer level where you're able to provide these really rich heads-up displays overlaying like an actual facility. Maybe the facility is virtual, maybe it's right in front of you, and you're being fed information that you wouldn't have access to otherwise from other systems that are bringing things in. I can look at something over here, see its temperature, etc. Look around the building, see where the hotspots might be. This machine over here is overheating, and I can see that kind of in real time. So the ability to kind of enhance your workers, give them more information than they would have access to with just their like human senses is something that's like really compelling, and it's like really easy to wrap your head around in terms of like the sales pitch for a digital twin. That said, you don't necessarily need that level of investment, but if you can get there, it's really cool, right?
Yeah, and bearing that in mind, there's the analogy, the best time to plant a tree is 20 years ago. By the time your Apple Vision Pro is like $10 or built into your own spectacles that you've bought at the opticians the other day, you'll really thank yourself for having built that data way back. But I think when it comes to those kind of interfaces, again, it's coming back to that aspect of being able to see something that you couldn't see before. I think another really interesting aspect to that is tying that together with what we were talking about earlier about not being able to be in the place. For example, maybe within your company, you have a series of factories throughout the United States. And each of those has got a technician on the ground, or maybe there's a team that goes from factory to factory. But the subject matter expert that knows how to use machine A or machine X or whatever is in Denver or is in, I don't know, Omaha, and isn't able to be on the spot, or not for every job. They can, however, put on a virtual headset and see an example of that there. In fact, they don't even need a virtual headset. You can have a 3D model or something somewhere. And between that and the person on the ground, you're then able to start saying, oh, okay, this is how we maintain this machine, or this is how we fix it. This is something we didn't do in training. This is how we go and deal with that. You also can have the situation whereby that knowledge doesn't necessarily need to be delivered live by the person. Maybe you've trained an LLM or something along those lines to have that information, and you just look that up on the spot. Hey, I'm seeing this. What might this be? Oh, try this, try this, try this. I think all of those are very interesting and compelling things, but I do want to be mindful that the more we talk about the shiny, exciting things, the less it seems like, oh, but I can use this on my production line now. And like Jason said, sometimes all it takes is a Raspberry Pi or a sensor you can buy from $10 off of Amazon,
Exactly.
slapped to the side of a machine, and all of a sudden you're generating insights and you're understanding more about how your production line works.
Yeah, I think that is a pretty clear tie in back to the idea that like collecting data is what matters in order to get these insights. You have to have access to something about the environment that you're looking at. The more data you have, the more capable you are of doing some of these fancy things, but it's also just improving your ability to reason about the environment and make good predictions and good models.
Yeah, I love that. I think it's reinforcing the idea that the bar to clear before you're on your way to some digital twins is actually not that high. It's just good practice to think about in any operation. Where do you have blind spots, and where are there places where you could be pulling more data to inform insights to improve your likelihood of making the right decisions and making sure you're not missing opportunities that are costing you and your organization. I think those are themes that are pretty consistently what we hear from clients in the industrial space in terms of challenges that they're trying to address.
Yeah.
All right. Well, this was fun. I feel like we ended on a really good point right there. So it's as good a spot as any to wrap this up. Thanks, both of you, for popping on to the Modern Industrialist. This was a blast. I'm glad we got to do this together. I feel like we took one of our normal weekday chats and just started rolling tape on it, which is one of my favorite things to do.
Yeah, absolutely.
All right. Appreciate you both. We'll definitely have to have you both back. All right. So I want to thank all of you for joining us today. If you enjoyed this episode, please subscribe so you don't miss any of our upcoming episodes. Our ambition is to continue to cover the important topics and trends shaping industrial innovation, spanning everything from manufacturing to supply chain. We'll see you next time on The Modern Industrialist.